The boot process, a step-by-step guide to powering your system. The boot process is an essential sequence of operations that every computer undergoes to transition from a powered off state to a fully functional system. This journey, which begins the moment you press the power button, involves intricate steps to prepare both the hardware and software environment for seamless user interaction. Let's explore this process, its significance, and how to address potential errors. What is the boot process? The boot process is a well orchestrated sequence designed to, first one, initialize hardware components. Load the operating system kernel into memory. Prepare the system for user interaction. From powering on to reaching the user interface, the boot process ensures a stable and functional computing environment. Next, sequence of the boot process. Step 1. Power on. The journey begins with the press of the power button. The computer receives power and the CPU immediately starts executing instructions stored in the system's firmware. Either BIOS, that is Basic Input Output System, or UEFI, that is Unified Extensible Firmware Interface. Step 2. BIOS or UEFI initialization. BIOS or UEFI is firmware embedded on the motherboard. It initializes and tests key hardware components such as RAM, CPU, and storage drives. This setup ensures that the system is prepared for the next phase. Step 3. Post, that is power on self-test. Post is a diagnostic process that verifies the functionality of hardware components. Any issues such as faulty RAM or missing drives trigger error codes or beeping sounds, guiding users to the root cause. Moving to the step 4, bootloader activation. Once post is complete, the BIOS or UEFI searches for a bootable device, that is, example hardware drive, SSD, or USB. It then loads the bootloader from the master boot record or GUID partition table, that is GPT. The bootloader such as GRUB or Windows Boot Manager is the bridge to the operating system. Step 5. Loading the operating system kernel. The bootloader locates and loads the operating system kernel into memory. The kernel is the core of the operating system, managing interactions between hardware and software. Moving to the step 6, kernel initialization. At this stage, the kernel initializes drivers for hardware components such as network adapters and sound cards. It mounts the file system and starts essential services required for the operating system's functionality. Now moving to the step 7, user interface setup. Finally, the operating system launches the user interface, either a graphical user interface, GUI, or a command line interface, CLI. The system is now ready for user login and interaction. Types of boot process. First one, cold boot. A full system restart initiated by turning the machine off and back on. This process includes a complete hardware initialization. Second one, warm boot. A restart triggered without powering off, typically through the operating system's restart option. Warm boots bypass post but reload the operating system. Third one, network boot. The computer loads the operating system over a network connection using the pre-boot execution environment. It's common in thin clients or large IT deployments. Next, safe boot or safe mode starts the system with minimal driveways and services, ideal for troubleshooting issues. It's available on both Windows and Linux. Next, importance of the boot process. Understanding the boot process is crucial for first one, troubleshooting boot failures. Identifying and resolving issues like BIOS misconfigurations or corrupted OS files. Optimizing boot times. Streamlining startup by disabling unnecessary services or components. Third one, firmware upgrades. Keeping BIOS or UEFI up to date for hardware compatibility and performance improvements. Now, on to the different errors during boot. First one, post errors. Beep codes or error messages indicating hardware issues like faulty RAM or disconnected peripherals. Bootloader errors. Problems with the bootloader can result in errors such as no boot device found or GRUB error. Next, kernel panic associated with Linux or blue screen of death associated with Windows. Severe errors during kernel loading, often caused by hardware failures or incompatible drivers. Slow boot. Disabling unnecessary startup applications or services can significantly improve boot times. Summary. The boot process is a multi-stage sequence. Powering on the computer, initializing hardware through BIOS or UEFI, running POST to verify hardware functionality, activating the bootloader to load the OS kernel, initializing the kernel and hardware drivers, setting up the user interface for interaction. The boot process is the backbone of any computing system, ensuring that hardware and software components work in harmony. Understanding its steps provides invaluable insights into system functionality and troubleshooting. Whether optimizing boot times or resolving errors, mastering the boot process is a fundamental skill in computer science.